Hello, this is Walker Physics, 4th edition. We're in Chapter 7 on work and kinetic energy, and this is the end of the chapter, questions number 19. How much work is needed for a 73 kilogram runner to accelerate from rest to 7.7 meters per second? Well, so far we've worked with work being the force multiplied by the distance, or the force being exerted through a distance. We're also going to see that, and the answer is in joules. We'll see later that energy also is in joules. So kinetic energy, energy due to motion, is in joules. Potential energy, energy due to position, is in joules. And the kinetic energy formula is 1/2 mv squared. So as it gets faster, it has more and more energy. Okay. Well, what's happening in order to if you have energy, it is able to do work. Energy is what is used to do work with. So for instance, if I have $100 and I put $100 in the bank, I now have $100 to use with my checkbook or use with my debit card. So the energy that you have can then be spent to do work. That's why they're both in joules. Work is in joules and energy is in joules. Well, we're going to see that force times distance and 1/2 mv squared are both equal to work. Because if work and energy are the same, if the amount of work you do is based upon the amount of energy you have, then 1/2 mv squared, which is equal to the energy that I put in to do the work, is equal to the work that I can do with the energy. All right. Now on the right, I've derived this for you so you can see it. All you do is you do Newton's law, force equals mass times acceleration. There's the average velocity. Okay. Then if I have v sub I as 0, then I only have v sub f. And then when I put them together, I end up with the t's canceling and m times the square of the velocity over 2, or 1/2 times that. Okay. So I can set these equal together, and I can say that work equals 1/2 mv squared. The reason why that I want to go this way is because I am accelerating. That means that I am interested in how much speed. I'm interested in the speed. Okay, and there is no speed when I have force times distance. So I need to do an identity so that I can get something that's equal to this with the units that I want to use, because I'm given my velocity of 7.7 meters per second, and I know how heavy this guy is. All right, so if work now equals 1/2 mv squared, the math is simple as it can be. It's just going to be 1/2 times the 73 kilograms times the 7.7, and I have to square that. That's meters per second. It gives me 2164 joules. And since this is two significant digits here and here, that'll reduce down to 2200 joules. So I've done 2200 joules by moving him that fast. So if you have velocity and you're asked to do work, you need to use 1/2 mv squared as your formula rather than force times distance. They're the same. Okay, they're derived exactly the same. But if you have velocity, I need to have some way to put that velocity in. And so I have to use the other formula. And we'll be using this again and again, so it'll become common for you. Okay? Thank you.